Hi students, I'm Anu Priyadashni, Assistant Professor, ECE Department, SRM Madurai College for Engineering and Technology. So today we are going to see about multiplexes. Before that, we will see two different types of digital circuits. One is combinational logic circuits, the other one is sequential logic circuits. In combinational logic circuits, the outputs depend only upon the present inputs. It does not have a memory element. Whereas in sequential logic circuits, the output not only depends upon the present inputs but also upon the past states. So these sequential logic circuits, use flip-flops or memory elements to store the information. So it has a memory element, whereas the combinational does not have a memory element. It only depends upon the present inputs. So some examples of combinational logic circuits are mux, demux, that is multiplexers, demultiplexers. In this class, we will be seeing about multiplexers. In the next class, we will see about demux. So encoder, decoder, adders, subtractors, everything comes under combinational logic circuits. So some examples of sequential logic circuits are flip-flops, counters, and registers. Okay, mux. Multiplexer has multiple inputs and a single output, whereas a demultiplexer has a single input and multiple outputs. So we will see this mux in detail now. So you can see the application of mux and demux here. For example, we'll consider this multiplexer here, which has four different inputs, and one output to a sound system. So, how to select what input has to appear at the output is done using select lines or control lines. So, for example, here you can see A and B are select lines or control lines here. If it is 0, 0, the MP3 appears at the sound system or it is heard at the sound system. If it is 0, 1, it is from the laptop. If it is 1, 0, it is from the digital satellite. If it is 1, 1, it is from the cable TV. So here you can see the opposite of it. So from this system, it is going to one of the four outputs, right? So 0, 0. If the selection line has 0, 0, so the information is passed from the system to the laser printer. For example, if it is 1, 0, the information is passed through to the color inkjet printer here. So we can say another example. Let me take a pen here. So imagine you have four CCTV cameras placed at in different locations. So you want to monitor all four CCTV cameras on a single screen. So here you can use a 4-to-1 multiplexer so that you can switch between the camera inputs using the select lines. So what is 4-to-1, 8-to-1? We will see that in next slides, the types of multiplexers. So multiplexers, we have studied that it has multiple inputs, but we cannot say that it has multiple inputs. So that's why we are going to name it as n number of data inputs, n number of inputs and one output. So from this, how can I decide the number of select lines or control lines? For example, if I have four different inputs as seen in the previous example, now I'm going to find out the number of select lines needed. So I'm going to use this formula 2 power m. So what will be there in this? What will come here in the powers of 2 so that I can have 4? So 2 power 2 makes 4. So I'm going to use 2 select lines here. So for example, if it is 16, I have 16 different inputs. How can I write 16 in powers of 2? 2 power 4. Yes. So how many select lines are here? 4. There are 4 select lines used. 16 inputs, 1 output and 4 select lines. So there are different types of mux: 2 to 1, 4 to 1, 8 to 1, and 16 to 1. So you can see here 2 to 1 multiplexer. 2 to 1 means the inputs here are 2. There is only one output. Then how to decide upon the select line used here? So there are two inputs. So how to write that in powers of 2? 2 power 1. So I'll be having, sorry. So I'll be having one select line. So that one select line is named as S0. Okay. Yes. Two inputs I0, I1, one select line and one output Y. So we can see here, if the select line has the value 0, the information at I0, the input which comes in I0 will be there at the output. If the select line is 1, has the value 1, I1 appears at the output. So how to write the expression for this? You can write it using sum of products. Sum of products. So S bar, that is for 0, I0 plus S into I1. So we can draw the corresponding diagram using logic gates. You can see here I0, so S bar, so this AND gate. So AND gate here, so this AND gate, first AND gate. For this S into I1, another AND gate, S into I1, another AND gate. After that, both things are added here. So an OR gate here. So this is 2 to 1 multiplexers. So 2 to 1 multiplexer has two inputs, one output and one select line. Okay. The expression you're going to write it as sum of products in the corresponding diagram here. So coming to 4 to 1 multiplexers, 4 inputs, one output. You can see here 4 different inputs, one output. How to decide upon the select lines or control lines? So we have 4 inputs, 2 power 2. So the number of select lines is 2, S1 and S0 here. You can see here, if S1 and S0 takes the value 0, 0, the corresponding output will be I0. If it takes 0, 1, the corresponding output will be I1. For 1, 0, I2 comes at the output. For 1, 1, I3 comes at the output. So this is the sum of products term. S1 bar, S0 bar into I0 plus the second row. S1 bar, S0, I1. The third term, third row. S1, S0 bar, I2. Fourth term, fourth row, S1, S0 into I3. So sum of products and the corresponding diagram. So the first one alone I will explain here. S1 bar, S0 bar, I0 here. So I0, S1 bar and S0 bar. So AND gate and the final expression is OR. Okay, a 4 input OR gate is used here. So this is 4 to 1 multiplexer. So this is 8 to 1. So we have 8 inputs, 1 output. So 8 input means in powers of 2, how will you write? 2 power 3 here. So there are 3 select lines, S2, S1 and S0, 3 select lines. So if it is like 0, 1, 1, I3 will come at the output. For 1, 1, 0, I6 will appear at the output. So these are the types of multiplexers.